Hi, I'm Miss Davis. Today we're going to be looking at a very common misconception when adding fractions, and that is that when 2/3 is added to 1/2, the answer would be 3/5. This is a very common misconception when first starting adding of fractions, and we're going to be looking at that. This is related to the Alabama standard from the Alabama State Department of Education, the math standard from 2019 of 5.9. Model and solve real-world problems involving addition and subtraction of fractions, referring to the same whole, including cases of unlike denominators, using visual fraction models or equations to represent the problem, and use benchmark fractions and number sense of fractions to estimate mentally and assess the reasonableness of answers. Also related to the mathematics standards from 2019 of 5.10, add and subtract fractions and mixed numbers with unlike denominators, using fraction equivalents to calculate a sum or difference of fractions or mixed numbers with like denominators. So the first thing that I would do when given this misconception is I would talk to my student and I would say, you're on the right track here. But with our fractions, we have to look at the denominators, which is the bottom number. And here, our bottom numbers are 3 and 2, which are different. So what we have to remember that fractions represent part of a whole, and the whole is your denominator, it's your bottom number. So when we have two different wholes, that's not going to work. We're going to have to find a common denominator so that we can then add parts of the same whole together. So this is a common mistake when first adding fractions, and because of that, we're going to look at some manipulatives and some visual models that will help us get a better representation. And so we're going to get some mathematical cubes together. And this is going to help to build conceptual understanding and support student learning when teaching fractions. And this is an effective teaching strategy which will help the students grasp the why behind mathematical procedures and not just the how. So when using the mathematical cubes, I'm trying to get mine put back together here. We're going to look here, and I've got this represented with these manipulatives. Ooh, there we go. And we've got both fractions represented. We have 2/3 represented here, the 2 being what's represented in the yellow. The numerator is the part of the whole. Then we have 1/2 represented here in the yellow, and the yellow being the 1, what is represented in the numerator. So if we're looking at this with our mathematical cubes here, and we can ask the students, okay, what do these number lines have in common here? And they would be able to recognize that there are 1, 2, 3, 4, 5, 6 in each row. So our whole here is 6. So then if we're going to add just the yellow is representing our numerators. We can take our cubes and add them together. Now we need to see how many we have of the whole, remembering that the whole is 6. So we have 1, 2, 3, 4, 5, 6, 7. So we've got one whole line of 6. And then, let me get all of my manipulatives together here. We also have 1/6 as well. So we have 1 1/6 or 7/6. And this hands-on learning with the physical options, with the physical objects, is going to help make it more concrete and make the abstract concept of adding fractions more tangible. Another way would be looking at a visual model and having the students visualize and draw that. So you could have the students draw a circle and then divide it into 3 equal parts. Then you can have the students with one color in from our first one. We have 3 equal parts, so 3 is our whole here, and color in 2/3. They can color it in, and this is going to really help them visualize and see what happens when you add these two fractions together. Now, on the same circle, have the students divide it into 2 equal parts to represent the 2 wholes here. 2 equal parts, and then color in 1/2 of that, one of the 2. This will help the students understand and see that it's going to be one whole for sure, and then there's even going to be some over the whole sorry, I dropped my additional phone there, but 1 over the whole, that's going to give us 5, 6. That will help them to visualize and have a more concrete understanding as to why we need to find a common denominator here. And after having these visual models to help them have an understanding of the why, then we can go over the how to do that. So when we're looking at moving past just the conceptual understanding, which has built a foundation, we're going to go over to the how. And we're going to look at that and we're going to say that we're looking to add these fractions. Now, we need to get the same denominator because we want to be adding parts of the same whole. So what is some multiples of 3? When we're doing multiples of 3, the students would tell us that we have 3, we have 6, we have 9, we have 12. Okay, those are some multiples of 3. Let's look now at some multiples of 2 so that we can find parts of the same whole using a common denominator. What are some multiples of 2? We have 2, we have 4, we have 6, we have 9. Hopefully, they would have caught on that we have something in common here. We have 6 in both of them. Both of them have a common denominator or common multiple in 6. So we're going to set up our fractions with our whole, our denominator, being 6. So setting that up, how many multiples of 3 go into 6? 2. So if we've got 2 multiples of 2, 2 times 2, it is 4. So that gave us an equivalent fractions. 2/3 is equal to 4/6. Okay, we want to do the same for 1/2. We've got our whole, our common denominator of 6. How many multiples of 2 go into 6? And they know that 3 do. So then 3 multiples of 1, 3 times 1 is 3/6. So 3/6 is equal to 1/2. Now that we have set up our common denominators and we are adding fractions with the same whole, we're adding parts of the same whole, we can add straight across here, but we know the first thing, our denominator is going to stay the same because we are still adding parts of the same whole. So 4 plus 3 equals 7, and that will help the students to then see the how to do it, the procedural fluency. Now that they have a more concrete understanding of it using the manipulatives, they will understand why that when they set it up this way, it equals 7/6, as opposed to just being taught the rules and how to do it. They will also be able to visualize and have a more concrete understanding of why 2/3 plus 1/2 does not equal 3/5, but equals 7/6. And that is the teaching strategies that I would use to address this common misconception and hopefully be able to build not only procedural fluency, but conceptual understanding with my students.